Okay, now we're going to look at some controls on the kidney function. There's normal drops in osmolarity. That is, you sweat a lot or you get dehydration or whatever. It's going to stimulate the hormone, antidiuretic hormone, called ADH. Now, what this does, if we look closely at this side of the diagram here, what's going to happen as that hormone gets stimulated is that it's going to increase the permeability in the collecting duct for water. So, in other words, we can reabsorb some more water back into the system. It also causes thirst, so that means that it's going to make you want to drink more water. And both of those things is going to increase the amount of water that you have in your bloodstream, and that's going to return you to normal homeostasis or blood osmoregularity. But, over here, this is the stimulus. That is, if you get a drop in that, it's going to cause ADH to be produced. So that's kind of like the normal feedback loop. This is called the negative feedback loop. Likewise, if you got too much water in there, then ADH would go way down, and then the permeability in the collecting duct would go down, and you'd absorb less water. So that's how that works. By the way, alcohol or caffeine interfere with this because they inhibit ADH. So even if your osmolarity was high and you needed to absorb more water, alcohol and caffeine would interfere with ADH and cause you to absorb less water. All right? So that's why alcohol is dehydrating, and after you drink, you should drink a bunch of water. All right, so then there's a whole nother system. This system is on the right-hand side of the diagram. This is a system that is for injury. I'm going to back up so that you can copy down some of the things that you'll need for this. This is called the RAAS system, or the response to response to low salt or body fluids. This is usually caused by injury or diarrhea, or your blood pressure goes down. Let's say you lose a lot of blood, and this is going to set up a whole series of reactions that is going to bring about your homeostasis. All right, so let's kind of go through that. This part right here is called the juxtaglomerulus apparatus. Whoops, I'm sorry. And what that is cells that are surrounding the afferent arteriole, and they will produce an enzyme called renin. So what renin will do is renin causes a blood protein angiotensinogen to turn into angiotensin II. And that will then go to your adrenal glands and cause another hormone called aldosterone to increase the sodium and water absorption in your distal tubes. So you can reabsorb back some water, some sodium too, so that you're likely to take up water from, or keep water in from your cells. And it also causes arterial, this hormone also causes arterial constriction, which means that it's kind of like making your blood pressure go up. In other words, it's sort of like holding your finger over a hose, and it causes the pressure to increase. So both of those make your blood volume go up and your blood pressure go up to counteract that loss in volume. And of course, the stimulus to that over here is the loss of blood or loss of fluids. Okay. All right, so in that whole system, it's called the RAAS system, and it is counteracted by this system, the ANF system, arterial natriuretic factor. And what that does is that as the blood pressure goes up and the volume goes up, renin release goes down. So basically it just turns off the JGA cells from producing renin.